Hi everyone. So today we're going to solve the problem Leetcode problem integer to English words. So let me explain the question first. The problem statement is we need to convert a non-negative integer to its English words representation. So here are the examples. 123. Yeah, we have to convert it into English number format. Like for example, if we go to the bank, when we give a check or deposit slip, we have to write it in numerical form and also in English letters. So that's what we are essentially doing here. So it's the question is pretty much very understandable and simple. Let's understand it with one example. So let me go to my notepad. Okay. So let us take one example. So here we have like this is the integer given, suppose. So first of all we have to divide this into ones, tens and hundreds, thousands and millions. One thing is in the question we don't have lakhs. Like in Indian system we have ones, tens, hundreds, thousands and lakhs and 10 lakhs like that, right? But here we have after thousand we have million and then billion. So regarding that I have like we have to divide the given number into like separate the thousands part, which is this essentially less than million. So that's how we read, right? If, for example, to write this in English, we'll start from here. This is thousands place. So this 12,000 we have divided it, and then next place is hundred place, which is essentially less than 1,000. So that represents 300, and then next is tens place, which is less than 100. So that is 40, and the last is ones place, which is less than 10. So the last one is 5. If we combine this all strings, 12,345. This is how we, even in our mind also, that's how we read it. So essentially we are going to do this same algorithm only. So in order to do this, first of all we need to have base to build the string, right? So the bases are below ones, below tens. Like these are 1 2 3 4 5 6 7 8 9. So these are needed to build the string that converts the integer into the English format. So next is below 20. These are 10, 11, 12, 13, 14, 15, 16, 18, 19, and yeah, and below 100. These are 10, 20, 30, 40, 50, 60. Using these three bases, we can create all combinations of numbers, and after 100 we can simply, for example, here if we see 300, we essentially have to take the number from ones and then add 100 to it. Same for 1,000 also. Same for 1,000, 40,000 as well. Like we have to take the 40 from here and then add 1,000 to it. Same with million and billion. So the basic blocks for solving the problem are these three arrays. So let's go into code. Let's start the coding. Okay, let me. Uh, okay, so we use a recursive approach. Like given a integer, first of all we try to take out a first number or the maximum possible. For example, here we have 123. So first we have to create the sentence 100, then pass 23 to our function. That again converts 23 into 20 and passes 3 into the same function, and then we convert the 3 into English 3 letters. So that's how we are going to do. So let me start the coding here. First of all, we have to consider a base case. If num equal to 0, we simply have to return 0 as string. Return, sorry, return 0. Wait a minute, just. 0. That's what, okay. Else we'll create a function, a recursion function. We just simply pass the number to that function. Number to words. So let's call the function as convert numbers to words. Uh, Pass this nums into this. So let me create a function, and it returns public string. It returns a string. So that takes input of type integer. Yeah, we return some answer. And before doing this, we have to declare these three arrays in Java. So let me initialize them. So since we are having two methods, and essentially these will be constants, like the ones below 20, below 100, these will be constant. I'm declaring it as a class variables. You can even declare them inside this convert numbers to words, but I'm doing this to public static string array. Let's call this once, maybe once equal to, I'll copy this from here, public static string, and another one as below 20, 20 equal to, let me just copy from here. Okay, and then again same, below 100 is equal to, copy from here. Yeah, okay. Now we're returning, we have declared the class variables, return, and now we have to complete the function convert nums to words. This will essentially convert it will be the recursive function we call again and again. Okay, so first thing we are going to do here is write the base case. If number is less than 10, what we have to do? We have to return once based on the ID. Like for example, if the index is 1, let me go to the ones array. Here, if the index is 1, like if the num is 1, index will be 1, so we'll return 1. If the index is 3, the element in third index is 3, so simply it will return the number. Similarly, if else if whatever, if num is less than 20, what we have to return? Similarly, we have to return the below 20 based on num. So for example, the number is 11. We have to what we have to do, we have to return index 1. So that's why we are simply minus the 10 from num, so that the correct word will be returned. Similarly, if num is less than 100, what we'll do here, return below 100. And how we'll return it, to get the correct index let's go here. So we have in first index we have 10. So in order to get the index correct, we have to divide it with 10. That's what we have to do to get the index. So num divided by 10, so that will essentially return the required word. And after returning like for example, if we have let me comment 143, after dividing with sorry, if num 43, after dividing with 10, we get 40, since it is a 4, since it is a integer. In fourth index, what we have here, 0 1 2 3 4 40. So that we get. What about the 3 here? So that's why we have, after getting the word for 10th place, we have to again call this convert this number, sorry, let me just copy this function. Okay, convert this number and pass the remainder. So like as explained, num 10, whatever remainder we get, we have to pass this also. And when will we do it? If for example 43 is there, then we are getting 40 from here, and we have to get the 3 from here. Essentially we are passing the remainder. What if this is 40 only? How will we do that? So in order to do that, we have to check that before itself, that num by 10 is not equal to, so if the remainder is not 0, then we'll return the number we have after converting to the words. If it is 0, then we simply return an empty string. So now going to the next kind of number. If the number is less than 1000, example, let's consider example 443. First of all, we have to extract 4 from this and add 100 to it. So that's so to add it, we'll pass the, sorry, the mic, okay, we'll convert bus to, and then pass by dividing the num with 100, because we have to get the number in the hundreds place. And then to that we add 100, we add the string 100, give us some space as well, 100. Yeah, that's, so after adding 100, there is still some part left, 443. So this will be the remainder after dividing the num with 400. So and same like before passing the remainder to it, this could be 400 as well. So for that we have to check whether the remainder is 0 or not. Similar to above, we divide num with 100, and if it doesn't equal to 0, um, we we add some space, and then again call the function convert number to words. So I made the function name a little complex. It's taking time to type it. 100. So that's if it is equal to 0, then we'll simply return an empty string. Empty string. That, that's pretty much it. Let me remove the comment. Now, in the given question, after thousands, we get after if next condition is if num is less than a million. Num is less than a million. There are three, yeah, six zeros in a million. That's essentially 10 lakhs. So the next condition is if the num is less than a million, then we first of all we should be having thousands only. So we'll start by returning uh, calling the same function, recursion function. We divide now with thousands because after a million in the given system will essentially be having thousands. In order to extract thousand, how many thousands are there, we have to divide it with thousand and then add the text thousand. Thou- Thousand. I hope the spelling is correct. Sorry, forgot to add plus here. Okay, after this similar to above, we have to for example, if you have 90,453, then after dividing we get 90. That is fine. That's we are passing here. But what about 456? This we have to again have to call a recursion call. So that's why we check the similar to above. We check we are getting any reminder or not. If the reminder is not a 0, then we can simply call the function again and then pass the reminder to it. 1000. If not, then we can simply return an empty string. uh, Now again same. If now the after a million, the next big number is billion. Billion. So now we have to check if the num given is less than a billion. How many numbers are there in billion? Okay, nine zeros are there in billion. So let me remove this example. uh, yeah, again the same thing. Let me just copy from the above and change the names. So in order to get how many millions are there in a like in the number, we just have to divide it with a million. And here also same, after dividing it with a million, we have to get a reminder and pass that reminder to the recursion function. uh, this will you have to change this to 1000 to billion. Sorry, billion. And then after if the number is greater than billion, then the highest digit is the billion itself. So we simply start returning. Again, let me copy from this here. We just have to change the numbers. That's all. The number of zeros here. Let me copy from. So what is, yeah, this is not working. Yeah, I have to add number billion here. 1, 2, 3 billion. Add 3 zeros. Yeah, that's pretty much it. Now let's try submitting if I had done any mistakes. What's the issue? Okay, I forgot to give the semicolon after declaring the array. Mm, expected. Okay, I forgot to give semicolon somewhere here. Not find symbol return line number 12. Convert to what's okay. Um, function and types. There are a lot of typing mistakes. Again a mistake below. Okay, again typing mistake below. I don't know how many typing mistakes are there. Okay, convert, not sorry, convert numbers. Yeah, there are a lot of typing mistakes, but the solution worked correctly. Let me submit it to check if it fails into any test case. Yeah, it worked. So uh, let me analyze the time complexity. So here, this is the main function. We're taking num. If num is 0, we're returning and calling a recursive function. So recursive function. So for every possible, and so the time complexity will be log of n, because the number of recursive calls here is proportional to the number of digits in number. So that's why the time complexity will be log of n. And also we are using recursion here. So see, every time we are having a recursive call uh, to the digits after the higher digit. So the space complexity will also be log of n, because we are using recursion here, and it essentially takes a stack of storage. That's why log of n. So it's pretty much simple. There are a lot of typing mistakes I had. So and one thing, since we are using recursion here, it is taking some space complexity. If you want to reduce that space complexity to constant, then we can use iteration solution also. So if you want, you can try that. Yeah, and that's it for today. Thank you.